Alright, so with this method, the main thing with this problem is the fact that they give you something right away. They tell you a criteria that's already met. So with the whole handwriting stuff, so the key things here, 77% of the volunteer subjects were correct for the female. 65% were correct on the male, and then 66% of the samples were female. Those are our three big things. And then what they say right here is suppose you know that the subject incorrectly identified a sample. So we know they guessed wrong. And then it says what's the probability that the sample was from a woman? And then round it to the 2 decimal places. So right here, that's why it was a little different than the one previously where you just multiplied it straight through. This one they tell you, okay, it was identified as an incorrect answer. Now, here's just a simple tree that was drawn. So 66% woman, correct 77, wrong 23. And then for man, 34% of the samples were men, and 65 right, 35 wrong. And what we have to do is we assume that it's wrong because it was told to us that it was wrong. And so when we're trying to find our probability for this, we're going to do the percent that the female is wrong, and then divide that by the percentage that anything could be wrong. And so what we have to do is we have to find, okay, what's the probability that out of all the samples it's a woman or it's a woman's sample and it's wrong. And so that's where we would just go 0.66 times 0.23 because it was woman and wrong. And so that would be the top part of our fraction. So that was the top part. And now we have to find, okay, well, what's the percentage that out of all the samples, what's the percentage that it could be wrong? So we have to look at, okay, the men samples that were guessed incorrectly and the woman samples that were guessed incorrectly. And so we would have to, on the bottom of this, we would want to take this part, 0.66 and 0.23, okay, which would be our first one. And then we would add that to the probability for the men, which would be, there's a 34% chance that a man's sample, and then there's a 35% chance that a men's sample is incorrect. And then from there, we would multiply those together. So 0.66 times 0.23 divided by 0.23 times 0.66 plus 0.34 times 0.35, and you would multiply those together and you would get 0.1518 for the top all over 0.1518 plus 0.119, and then that gets us 0.1518 all over 0.2708, and that gets us our answer of about 50 or 0.56 approximately. And so what's happening with this one is because it gives you the criteria that it was a false or it was an incorrect. So now what you have to look at is you got to say, okay, well, what's the chances that it's going to be incorrect? So how many total possibilities are there incorrect? I mean, a way you could think about this, another way is just taking, if you look back here, when you're looking at these, you go, okay, well, if there's 100 people, okay, that means that 66 of them are women, and out of those 66 women, 23% of 66 got it wrong. So 23 so 60 or 23% of 66 is 15.18 women. And now you look at the bottom, okay, well there's 34 men, and 35% of those 34 men got it wrong. And that would be about 11.9 men. And now you're just saying, okay, well if we know that it's wrong, how many wrongs were there? How many people got it wrong? And that would be the 15 plus the 7 plus the 11 added together. And that gets you your 27.08, which was the bottom of our fraction. And then how many were women? Well, the 15.18. So because it was given that, okay, this is what it is, it was wrong, we had to go through and kind of adjust what we were looking at. And so that's how it was a little different than just a straight multiplying straight through, because it gave you a criteria. So you've got to look and make sure you identify what the criteria is before you can move on to the rest of it.